Hello viewers, welcome back to our YouTube channel. We are still on the properties of binary operation and you are going to learn about the identity or neutral element for today. So as Ghanaians, we all have identity cards which shows that we are indeed members of this country. And this identity card have our faces on them. So when they compare your face to that on the identity card, let's take for instance a Ghana card, and it proves that you are the same person. It shows that you're a member of the country. So that's the main purpose of the identity element. So if you have a set of real numbers and you want to show that a particular number or a particular element is part of the set of real numbers, we'll perform an operation on that element with our identity element. And if you perform an operation on that element with the identity element, you are supposed to get the same that element you want to verify. But if you do it and you don't get that element as your result, then it means that that element doesn't belong to, let's say, the set of real numbers. So here we have, if E is a subset of R, E is a member of R. So if E, which is a member of R, is the identity or neutral element under a binary operation star on a set R of real numbers, then we say that A star E, which is equal to E star A, should be equal to A. So now it's like you want to verify if A is a real number, right? So if you perform an operation with A and our identity element E, you should get A. Or if you change the order and you perform the operation, our identity element, you perform an operation on our identity element and what you want to verify, you should get the same element you want to verify with. So if you check and you don't get it, then it means that that element doesn't belong to a set of real numbers. So let's try and see some examples on it. But before that, you have to note that for every operation, there is just one. There is only one identity element for every operation. Only one identity element. Let's take addition for instance. If you are adding, now let's look for a number that when you add to any other number, you get the number itself. So think of a number, 0. If you add 0 to any number, you get the number itself. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus A is A. 0 plus B is B. So we say that 0 is the identity element under the addition operation. So 0 is the identity element under the addition operation, because anytime you perform an operation with on 0 with any other number, you get the number itself. So it shows that 0 is the identity element for the addition operation. Let's come to multiplication 2 and see which number. Think of a number that when we multiply by any other number, we get the number we are multiplying it by itself. So let's take 1. If you multiply 2 by 1, you get 2. If you multiply 3 by 1, you get 3. If you multiply A by 1, you get A. If you multiply B by 1, you get B. So this one shows that 1 is the identity element under the operation multiplication. So whenever you perform an operation, which is a multiplication operation with 1 in any other number, you get the number itself. So 1 is the identity element under the operation multiplication. So let's try and see other examples and how they can frame questions for you. So let's take a look at this question. So the operation star is defined over a set of real numbers by A star B is equal to A plus B plus AB. Find the identity element under the operation star. So we've been given a rule for this operation and they want us to find the identity element under this operation. And from our definition, we've learned that for identity element, A star E, which should be equal to E star A, right, should give us A. So for this particular example, for you to be able to find your identity element, you either change A and make A your identity element, or you change B and make B your identity element. So we'll try and do any of them and see if you are going to get the same identity element for the operation. So first of all, let's make our B to be the identity element. So it means that now instead of A times A star B, we should get A star E, right? We are making our B the identity element. So if you perform this, we are supposed to get A, right? But then they've given us a rule for the operation. So we are come to put this inside the rule that they've given us. So we know that A star E should be equal to A. So if you come and put it inside the rule, you end up getting A plus, now in place of our B is E, then plus A E is equal to A. So from here, I come and put A star E into the rule. Then I get A plus E plus AE and I equate it to my A. So our main aim is to find the identity element. So we'll make E the subject from here. So if you take A to the other side, A minus A is 0. So you end up getting E plus AE is equal to 0, right? So now we are going to factorize E outside from here. So if you factorize E outside, you are going to get 1 plus A, which is equal to 0. Now, if you make E the subject, you are going to get 0 over 1 plus A. And 0 over any number is 0. So here we say that our identity element is 0. So it means that whenever you do any element, any number which is a real number, you perform an operation on any real number, then you can with 0, you should get that number. So I want us to now make our A rather the identity element and see if you are going to get the same answer. Yes, I just want us to prove. So let's do for that one. So now we are saying that we are changing our A rather to E. So our equation becomes E star B. So I said that whenever you perform an operation on the identity element and any other element, you have to get that element. And our rule was given to us as A star B is equal to A plus B plus AB. So now our E star B will be equal to, so I'm come to put E star B into the rule. So we'll end up getting E plus B plus EB, which should be B. I'm going to make E the subject. So I'll group like terms. E plus EB is equal to B minus B. E plus EB is equal to 0. When I factorize E outside, I get 1 plus B, which is equal to 0. So E is equal to 0 over 1 plus B. Then 0 over any number is 0. So from here, we've gotten our identity element to be 0. When we tried making B rather the identity element from here too, we are getting 0. So now I want us to use any number and see if when we do any number and 0 using the rule they've given us, we are going to get that number. So let's take any number. So let's take 3. So now it means if I do 3 star 0, I should get 3 because 3 is a real number. So let's put 3 star 0 into the rule, this rule. So you end up getting 3 plus 0 plus 3 times 0 is equal to, so let's see what we are getting here. 3 plus 0 is 3, right? Then 3 times 0 is 0. So what are we getting? 3. 3 plus 0 is going to give us 3. So this is telling us that our identity element 0 holds, because now that we are using a raw number 3 to do it, we are getting the same number. So this one is trying to tell us that now 3 is a real number. We can try any other thing, or we can even use the variables. So let's take a. Now identity element is what? 0. So if we take a star 0, you are supposed to get a. So we are going to put a star 0 into the rule. So if you put a star 0 there, you are going to get a plus 0 plus a times 0, right? So you get here a plus 0 is a, plus a times 0 is 0. So a plus 0 is going to give you a, which is equal to a. So now you are getting the same um element if you perform an operation on a and the identity element. So that's it about the identity element. It's just you being able to, so we are proving if a certain element belong to a set of numbers or a set of elements that you've been given. So let's see another example here. So identify the identity element for the operation star. So we are going to look for, from this table, we are going to look for one element that when we take the when we take the that element and any other element and perform an operation on it, we get the previous element itself. I'm sure I'm confusing you, so let's go to the table. So now let's see here. A star A is giving us A. A star B is giving us B. This same A star C is giving us C. So it means that whenever you perform an operation A star a certain number, a certain element, that's let's say I don't want to write a variable. Okay, let's say a certain element n, you get n. So when we come here and do A star A, you are getting A star B, where our n is B here, we are getting B. A star C, where our n is C here, we are getting C. We also learned that it should be commutative. So it means if you do n star A2, you should get n. Now let's take it this way. A star A, we are getting A. A star B, we are getting B. A star C, we are getting C. So even if you change the order, still you realize that whenever you perform an operation on A and any other element, we get the element itself. So here we conclude that our identity element for this operation is A, because whenever you perform an operation on A and any other element, you get the other element. So that is it for today. If you have questions or any comment, please let us know in the comment section, and see you in the next video. Bye.